So, should be all new to you. Transporter substances. Okay. What's happening here is this area here. How are we going to explain the filtrate? Now we got to go back to hydrostatic pressure, osmotic pressure, all that wonderful stuff. Like I said, the way the nervous or the nephron system or the urology system is, it's going to be the last piece of the puzzle. It's bringing back all the stuff, endocrinology, circulation. It's putting it all back in here. It's a conglomeration of everything we learned. So what we have here is this. Here's the afferent arteriole, here's the efferent arteriole, and we got capillaries, right? The glomerulus. So we got to talk about these forces again. We have hydrostatic pressure going this way and pushing it out into Bowman space. This is Bowman space over here, also known as urinary space. Okay? That's the space between the capillary and Bowman's capsule itself. That's space. So we have hydrostatic pressure that's going to go out. All right? That's what this red arrow is. So you have this hydrostatic pressure going out. Now look what's happening here. We have fluid that's going to go into this area here. So there's also hydrostatic pressure outside the capillary, in the Bowman space. Right? There's hydrostatic pressure in the capillary. You're pushing it out there, but as it's pushing it out there, you're putting more fluid in Bowman space. So now there's hydrostatic pressure that wants to go back this way. Does that make sense? There's fluid pressure going out, and fluid pressure going back in. Okay? That's what's going on here. So there is hydrostatic pressure of the capillaries here, and the blue is the hydrostatic pressure of the Bowman space. Now we also have oncotic pressure, or osmotic pressure, which is the pressure exerted by the proteins. And that's a drawing force, right? A drawing pressure to bring things back in. Now, we have proteins in the capillaries, because like I said, the proteins are not going out into the nephron. So, we have proteins in here that is going to draw the fluid back in itself, right? To dilute it. But that's what's referred to as the green arrow. So we have hydrostatic pressure pushing out from the capillaries, hydrostatic pressure that's putting it back in from the Bowman space, but we also have oncotic pressure of the capillaries that's going to draw the fluid also back into the capillaries because the proteins are in there. There are no proteins, supposed to be no proteins in Bowman space. So normally when we talked about the capillaries and we did circulation, there was 4 pressures, right? 2 oncotic pressures on both sides and 2 hydrostatic. But not here. We only have 3. We don't have an oncotic pressure in Bowman space because there is no proteins out there. Does that make sense? So we have 3 pressures. 2 that's going to bring the fluid back into the capillaries, and only 1 that's going to push it out there. All right? And whatever that is, it's going, when you add up those numbers, that's what's going to tell you if it's going to go in here or not. So, let's look at this. Okay? So what you've got over here is the fluid that's going to become filtrate. All right, so the fluid that's going to become filtrate, let's say, what was this? So we'll say the net outward pressure. How's that? That's even better. The net outward pressure. Right? That's going to go into the nephron is going to be hydrostatic pressure from the capillary, because that's the only one that's going to be pushing it out there, minus whatever is going to be pressure or forces pushing it back in. The hydrostatic pressure of Bowman's capsule plus the oncotic pressure of the capillary. Does that make sense? Look at the numbers up there. This is the one that's going to go out. This will push it back in. This will push it back in. That's how it came out. There is no oncotic pressure of Bowman's capsule because there is no proteins out there. Now, we just plug in numbers. The hydrostatic pressure of the capillary is, well, they're calling it glomerular, same thing, capsule. Let me take this, because you might think that's, let's say hydrostatic pressure of the glomerulus. That's better. Okay? Put down cap, you know, it's capsule versus capillaries. So, does that make sense? So, the net outward pressure is the hydrostatic pressure of the glomerulus minus, together, the hydrostatic pressure of Bowman's capsule plus the oncotic pressure of the glomerulus. And now you just plug in numbers. This will be 55, if I can give you the numbers. This will be 15 plus 30. See how I got those numbers? Following this picture here? Then you're going to get 55 minus 45, which means you're going to get positive 10. That positive is telling you that fluid is going through here. It's going into the nephron. Okay? Let me show you what's happening if we do different numbers. Does that make sense? We'll write it up here. We'll say that this is net outward pressure. All right, so I'll just write it again. Glomerulus minus hydrostatic pressure Bowman's capsule plus oncotic pressure of glomerulus. Let's say the person has low blood pressure. This is the significance I want you to see. They don't have high blood pressure. They're going to have low blood pressure. So let's say instead of 55 over here, it's 30. Just give me numbers. The hydrostatic pressure is going to be a little bit lower because there's not much fluid that's going out there. So we'll say that that's 5. But the oncotic pressure is still going to be 30. That's still the same. So now look at what I get. 30 minus 35, you get minus 5. That minus is telling me fluid is not going into the nephron. You see the significance? This is the significance I want you to understand about blood pressure. We've all heard that high blood pressure is bad for you. But when you have low blood pressure, the kidney is not going to function, and it's going to keep all the toxins and extra water and extra electrolytes in your bloodstream. Is that clear about that? Okay?